Welcome back. This is Mr. Hassan's Maths channel, and this now is question number 22 from the practice paper for the 2025 IGCSE 0580 Cambridge paper, this is the non-calculator paper. And this question here is about basically indices. It's all about indices and surd form. Okay, so in this question, we are told that the cube root of y squared is the same value as the sixth root of x, and that y is equal to some number, some x to the root of some number. So we've got to find the value of that number, the n here. So basically what we have to do is we've got to take this, the cube root of y squared equals the sixth root of x, and we got to make y the subject. We're going to make it say y equals. That should say in the end y equals, and then whatever's on this side, we can then work out what the end's going to be. Now, for a question like this, I personally think the easiest way to deal with it is to first rewrite everything in index form, and then once you've got what y equals, rewrite it back in the surd form. Way easier to deal with, I think. All right, especially when you're dealing with letters. With letters, I like to use index form. So we have to understand very clearly the important rule of indices. That if you have, for example, p, the mth root of p to the power of n, something like this. How do you write this in index form? Well, what you have to understand is that you're going to write that as a fractional index. When you have, square roots and cube roots and, roots, there will always be a fraction. And the numerator of the fraction will always be the number that is inside that the term inside the bracket is raised to. So here, this would be to the power of n. So p to the power of n over, and the root will always be the denominator. So the root is the denominator and the power is the numerator of the fractional index. Okay, so this will always give you a fractional index, something like this, and the power will always be the numerator of the fraction and the root will always be the denominator. Okay, so we have to understand that. That's very important for us to understand. So the power will be the root will be the denominator and the power will be the numerator. Okay, so if we translate that to this, then we can write this as y to the power of, remember the power is a numerator and the root is the denominator. So y to the power of 2/3 equals, and here it's like you've got a 1 here. So this would be x to the power of 1 over 6, because the root is the denominator and the power is the numerator. Okay, so we want to rewrite this. So now we've got no power with the y except for 1. We want to get rid of this. We want to rewrite this as y to the power of 1 equals. That's what I have to have it in the end. So what I'm going to do is, and with index form it makes it very easy, if I raise this to the power of the reciprocal of this fraction, okay, we know that if I have a power, something in index form raised to another power, I have to multiply the powers. Okay, so when I multiply this with 2/3, 2/3 and 3/2 cancel out, leaving you y to the power of 1. So we're left with what we need here, which is y equals. So I'll do the same thing for this. I will take this 1/6, and if I raise this side to the power of 3/2, I must do the same to this side. Okay, so I have to do 1/6 times 3/2. So 1/6 times 3/2. So what will happen here, this 3 will cancel with the 6, give you 2. You're left with 1/2 times a half, which is 1/4. So this will give you x to the power of 1/4. So if y equals x to the power of 1/4, we can rewrite this in terms of surd form because our n is the number that is a root. So this is going to be the same as the 4th root of x to the power of 1. So n equals 4. Okay, so I think this makes life way easier if we write things in index form when we have letters to deal with and then manipulate it to what we need. So there's your answer to question number 22. all about surds and indices. Okay, index form. So I will save this question in the playlist for the paper that this question is from. Also save this from the topic of indices, and also in terms of in the topic of surds as well, I guess. And you can see also here a playlist which is dealing with indices from the old syllabus, which will also be useful. Except in those older questions, we could use calculators to kind of like deal with it. Although this is algebraic, so it's not really that relevant. But you know, we were able to get some sort of help with calculators before. Now we cannot at all. So there we have it, the answer to question number 22. Thank you for watching, and see you soon.